Okay, last one. I'm going to plug 0 in for f of x because don't forget that y is the same as f of x. So I have 0 equals 2 times x plus 4 squared. And I want to get x alone. So I'm going to start by dividing both sides by 2. 0 divided by 2 is 0. And then we're left with x plus 4 squared. So now we've got to undo the squaring by square rooting both sides. And the square root of 0 is just 0. There's not two answers. And we get x plus 4. Okay, now we want to get x by itself, so we subtract 4 from both sides. And we get minus 4 equals x. And this might be confusing because we've talked a little bit about how there's two roots oftentimes with quadratics. Well, this is a case where there's one root. And so what does this look like? And this is a very, very rough sketch. Oh, geez, see, really rough sketch. So let's just pretend that was down where it was supposed to be. Okay, and if I'm going to do a sketch of this, well, this means that this graph crosses the x-axis at -4. So I can put a dot there, okay? And this is going to open up. It's not a negative outside here, so it's going to open up like a U rather than an upside down U. And so really, really poor sketch. It's going to look something like that. So this is an example of a parabola with one root. Okay, a parabola with 2 would look like this, right? 1, 2, whatever those would be. And a parabola with no roots could look like this. Notice it's not crossing at all. And hopefully we get to talk about that a little bit. That is a possibility. Those are called non-real roots. But we'll talk a little bit about that. But those are kind of those options. Don't be alarmed if you just get one root.